In this video we will talk about arithmetic or geometric progression. So let us consider this series where S is equal to a plus dr plus a plus 2dr square and so on. So you can see that this series is actually made up of the multiplication of the corresponding terms of arithmetic progression, which is a plus b, a plus 2d, and the nth term would be a plus n minus 1d, and it is multiplied by a geometric progression 1 r square r to the power n minus 2, and therefore nth term would be r to the power n minus 1. So if you multiply, let us consider this arithmetic progression. AP is a plus d, a plus 2d, and nth term would be a plus n minus 1d. And if you take GP as 1 r square and nth term as r to the power n minus 1, you multiply each of these corresponding terms and you get an arithmetic or geometric progression. Now, how to sum this progression? We will use a similar method that we use for geometric progression. So we will multiply both the left hand side and the right hand side by the common ratio r. So once you multiply this, so this becomes AR, so we write it over here, AR plus a plus dr becomes a plus dr square this will become a plus n minus 3 d r to the power n minus 2 plus a plus n minus 2 d r to the power n minus 1 plus, I write it here, a plus, this last term would be a plus n minus 1d r to the power n. Okay. Now let us subtract this equation. So you have 1 minus r times s, which is the left hand side, and you subtract this. So this is a minus 0, so it is a plus dr minus ar becomes plus dr, a plus 2dr square minus a plus dr square becomes dr square, this one becomes dr to the power n minus 2, this one is dr to the power n minus 1, and last you have minus, this is minus a plus n minus 1 d r to the power n, right. Now we will simplify this. So you have a plus, we take dr as common factor out, so you have 1 plus r to the power n minus 3 plus r to the power n minus 2 minus a plus n minus 1 d r to the power n. Now I want you to notice that this is again a geometric progression, and how many terms are there in this geometric progression? 1 to n minus 2. So there are actually n minus 1 terms in this geometric progression. Okay, this geometric progression over here has n minus 1 terms. Okay, so we can write the sum of this geometric progression. So this means that this is a plus dr how to write the sum of n terms of geometric progression? It is a times 1 minus r to the power n. So, a is 1, so it is simply 1 minus r to the power n is n minus 1, because there are n minus 1 terms in this, okay, divided by 1 minus r. Okay, I am simply using the geometric progression sum formula for n terms, minus a plus n minus 1 d r to the power n. So, what is sum finally going to be? Sum is going to be a divided by 1 minus r plus dr times 1 minus r to the power n minus 1 divided by 1 minus r square minus a plus n minus 1 d r to the power n divided by 1 minus r. So, this is how we can find the sum of a arithmetical geometric progression of n terms. Okay, we have, this is the formula for sum of n terms. Now, let us consider what happens when our absolute value of r. So, I will use a different color now. Let us say that absolute value of r is less than 1. What happens in that case? In that case, we can still write s is equal to a divided by 1 minus r plus, we will just now distribute this. So, this is dr divided by 1 minus r square minus dr to the power n minus 1 divided by 1 minus r, I am sorry, this is dr to the power n, right, r multiplied to r to the power n minus 1 is dr to the power n. One minus r square minus a plus n minus 1 d r to the power n divided by 1 minus r. Okay. Now, if mod r is less than 1, we know that r to the power n will go towards 0 as n becomes large, right. If n becomes very large, we know that r to the power n will become 0. So, in that case, if the absolute value of r is less than 1, we can find the sum of infinite series of arithmetical geometric progression, and that sum will be simply s is equal to a divided by 1 minus r plus d times r divided by 1 minus r square, right, because this term dr to the power n will tend towards 0, and this term a plus n minus 1 d, over here also you can see that there is r to the power n. So, this term will also tend towards 0. So, both these terms from here to here will become 0 as n approaches infinity. Okay. So, this is what you have, a formula for sum of infinite series of arithmetical geometric progression if the absolute value of r is less than 1. Now, using this formula, we will solve some problems. Okay, so let us look at the first three problems of chapter 5b of Hall and Knight higher algebra. I have already written the formulas that we derived earlier for sum of n terms, and this green formula is if the absolute value of r is less than 1, then this is the sum of infinite series. Okay. Now let us look at problem number 1. We have to find the sum of s is equal to 1 plus 2a plus 3a square plus 4a cube. So we can use the sum of n terms formula. Okay. Now sum of n terms is a by 1 by r. So in this case it will be 1 by 1 minus a, because the first term is 1, divided by 1 minus common ratio is a. So it is 1 divided by 1 minus a plus d times r. Common difference is 1 again, 1, 2, 3, 4, 5, 6. So if we see that common difference is 1, common ratio is a. So this is a times 1 minus r to the power n minus 1. R is a, so it is a to the power n minus 1 divided by 1 minus r square. So it is 1 minus a square minus a plus n minus 1d. So this is the nth term of the progression. So it is 1 plus n minus 1 times 1. So it is 1 plus n minus 1. So it is n, right? So this is n times a to the power n divided by 1 minus a. And if you simplify this, what you get is in fact this is the sum. Okay. If you want to simplify it, I can simplify it further. Let us say this is 1 minus a divided by 1 minus a square plus a times a minus a to the power n divided by 1 minus a square minus n times e to the power n divided by 1 minus a. So if you add these two, this a and this a will cancel, and what you will get is s is equal to 1 minus a to the power n divided by 1 minus a square minus n times e to the power n divided by 1 minus a. Now you can make this also 1 minus a square. So it is 1 minus a to the power n divided by 1 minus a square minus n times a to the power n 1 minus a divided by 1 minus a square. So what you get is s is equal to 1 minus a to the power n minus n a to the power n minus n minus is positive n a to the power n plus 1 divided by 1 minus a square, and therefore the final answer is 1 minus n plus 1 a to the power n plus n a to the power n plus 1 divided by 1 minus a square. So this is problem number 1. Now let us look at problem number 2. Okay. In problem number 2, what we see is we have 1 plus 3 by 4 plus 7 by 16 plus 15 by 64. So first let us write it as arithmetic or geometric progression, if we can write it. Okay. So this is S is equal to 1 plus 3 times 1 by 4. We can write it as 3 by 4, we can write like 3 times 1 by 4 plus 7 times 1 by 16 and plus 15 1 by 64 plus 31 divided by 1 by 256. Okay. Let us see if it is a arithmetic or geometric progression. It is 1 plus 2 is equal to 3, 3 plus 4 is equal to 7, 7 plus 8 is equal to 15. So it is exactly not a arithmetic geometric progression. In that case, I think it is better to solve it using a different method. Let us solve it like let us write it as 1 plus 3 by 4 plus 7 by 16 plus 15 by 64 plus 31 by 256, okay, and so on. We know that the denominators are 1 by 4, 1 by 16, 1 by 64. So we know that there is some common ratio which is 1 by 4. So let us multiply this side by 1 by 4s, okay, and what you get is 1 by 4, 1 times 1 by 4, 3 times 16 plus 7 times 64 plus 15 times 256 and so on. Okay. Next step, what we will do is we will subtract these two terms. So this is s minus 1 by 4s, so it is 3 by 4s. Okay, and you get 1 plus 3 by 4 minus 1 by 4 is 2 by 4, right. 3 by 4 minus 1 by 4 is 2 by 4 plus 7 minus 3 is 4, so 4 by 16 plus 15 minus 7 is 8 by 64 plus 31 minus 15. So it is 16 by 256, right. Now you can see that this is equal to 1 plus 2 by 4 is 1 by 2 plus 4 by 16 is 1 by 4 plus 8 by 64 is 1 by 8 plus 16 by 256 is 1 by 16. So is this a geometric progression? Is this a geometric progression? It is 1 times half, half times half is 1 by 4, 1 by 4 times half is 1 by 8, 1 by 8 times half is 1 by 16. So yes, this is a geometric progression. So this sum is equal to 1 divided by 1 minus 1 by 2. which is equal to 2, right. So what we know is that 3 by 4s is equal to 2. So what should be s? S should be 4 times 2 is 8 divided by 3, right. Now let us look at the last problem, which is problem number 3. Sum 1 plus 3x plus 5x square plus 7x cube. Now this one looks like an arithmetico-geometric progression for which we can apply the formula straight away, right. We have sum is, our series is 1 plus 3x plus 5x square plus 7x cube, right. So it is 1 plus 3x plus 5x square plus 7x cube plus 9x to the power 4 and so on, right, and we have to sum it till infinity. So we are assuming that modulus of x, okay, if we have to sum it till infinity, we have to assume that modulus of x is less than 1, otherwise this summation to infinity is not possible, okay. Now we see that the coefficients are 1, 3, 5, 7, which is actually arithmetic progression, and 1, x, x square, x cube, x to the power 4 is a geometric progression. So we will simply apply the formula that we saw here. It is a divided by 1 minus r, so it is 1 divided by 1 minus x plus d times r. What is common difference here? Common difference is 2, okay. D times r is so 2x divided by 1 minus x square, and if you want to simplify it, you can simplify it. This is 1 minus x plus 2x divided by 1 minus x square, and therefore you get x plus 1 divided by 1 minus x square, and we are done.